Today I will talk about effect analysis of observational studies. This is part of my series of lectures on cause and effect modeling. This is my lecture outline. First I will give introduction about variables, causal model, fundamental problem of causal analysis, ATE, ATT, CATE, bias, independence assumption, adjustment formula. Then I will talk about causal effect estimation. First of all, de-biasing by linear regression, then propensity score, then inverse propensity weighting, then standardization, then doubly robust technique. Then I will describe an example in Python code. Causality is something you might know as a dangerous epistemological terrain you must avoid going into. Association is when two quantities or random variables move together. Causality is one change in one variable causes change in another variable. It is important to note that association is not causation, but sometimes association is causation. Causal inference is the science of inferring causation from correlation and understanding why they differ. You want to know cause and effect relationship so that you can intervene on the cause to bring upon a desired effect. Whereas machine learning is predictive analytics, causal analysis is prescriptive analytics. Machine learning uses correlation between variables to predict one from other. Now, a little bit about variables. So, variables include a treatment variable. Treatment here means intervention. Let T sub I be the treatment intake for unit I. T sub I is equal to 1 if unit I received the treatment and 0 if unit I did not receive the treatment. Outcome variable is denoted as Y sub I and exogenous variables are denoted as U sub T and U sub Y. The fundamental problem of causal inference is that we can never observe the same unit with and without treatment. So in observation studies, particular unit may be with treatment or without treatment, it can never be both. So causal model is function of an exogenous variable U sub T determines treatment and function of treatment and an exogenous variable U sub Y determine an outcome. Expectation is written as marginal expectation is E x, whereas conditional expectation is E y subject to x is equal to x. Effect is equal to outcome variable for unit I which has received treatment minus outcome variable of unit I which has not received treatment. And potential outcome is outcome variable of unit I is equal to y sub I subject to do t sub I is equal to t. And there are two potential outcomes. One is y sub 1I, another is y sub 0I. Average treatment effect is the expectation of the effect of each unit, and hence average treatment effect is equal to expectation of outcome variable of unit I which has received treatment minus outcome variable of unit I which has not received treatment. And it can be written as this. Average treatment effect on the treated is given as expectation of the after effects of treatment and before effect of treatment of all those units who have received treatment. Conditional average treatment effect is expectation of outcome variable y1 sub I minus y0 sub I subject to that x is equal to x, where x is a confounder variable. Bias is what makes association different from causation. Potential outcomes. What would have happened to the treated had they not been treated? That is, units which have treated the effect before treatment. What would have happened to the non-treated had they been treated? So all those units who haven't been treated, the outcome after treatment, and both these entities are counterfactual outcomes because they actually not happen in reality. They are counterfactuals. So association is given as expectation of outcome variable of those treated minus expectation of outcome variable of those not treated, which is given by these two terms. And these two terms are nothing but the first term is the average treatment effect of treated, because here t is equal to 1. And this term is the before treatment effect of those treated. So this is counterfactual. And this entire term, second term, is the bias. Bias is given by how the treated and control group differ regardless of the treatment. That is, in case neither of them receive the treatment, because these are the units which are treated and this is before treatment. These are the units which have not received treatment. So their effect is in any case without treatment. So this entire term is bias. That is, in neither of them received the treatment. So if these two terms are equal, then bias is 0. In that case, association is the causation. Independence assumption is that both the potential outcomes are independent of treatment. That is, potential outcomes are independent of treatment. Adjustment formula. So this is the adjustment formula subject to the confounder variable's presence and independence assumption. And if outcome variable is continuous, we take the derivatives. This is the summary. This I have taken from this article from internet. So risk difference, the first one, is the average treatment effect. So this is the measure of causation and this is the measure of association. And risk ratio is for randomized study only. So the second entity, risk ratio, is for randomized studies only. Then there is another entity known as odds ratio. Then causal effect estimation. So first method is debiasing by linear regression. So first of all, we regress treatment variable t on confounders x and obtain the residuals. Then we regress outcome variable y on confounder x and obtain the residuals. So we have residual t and residual y. Then causal effect of t on y is given by regression of residuals y on residuals t. Second method is propensity score. Propensity score is written as this. It is the probability of treatment given the confounder variables. So the conditional independence can be written as in the presence of confounder variables. It can be written as that outcome variables are independent of treatment variable subject to the confounder variables. And since this probability. So we can write here as this. If treatment is binary, then logistic regression between T and X can be done. And then the propensity score is the predicted T here. And average treatment effect is coefficient beta sub T when we linearly regress Y on T and propensity score. So propensity score is after logistic regression and AT is after linear regression. Then another method is inverse propensity weighting. Inverse propensity weighting is based on the assumption that individual information that can predict the probability of inclusion is available for the entire study population. It involves building a logistic regression model to estimate the probability of exposure for a particular person and then using the predicted probability as weight in subsequent analysis. So first of all, we predict the treatment variable from confounders and then we calculate the weights on the basis of prediction and then we do further analysis. So weights are weight T and weight NT. Weight T is the inverse of propensity score for units which are treated, and weight NT is inverse of propensity score of units which are not treated. And average treatment effect is given by this formula. Basically, we multiply the outcome variable with the weights of the units which are treated and which are not treated. And another formula for average treatment effect is this. Then the another method is standardization. Using the standardization method, once this probability is calculated, the causal estimate can be straightforwardly computed since probability that C, here C is the confounder variable which was X previously in our lecture, can simply be replaced with 1 by n, with n representing the sample size. Probability that y is equal to 1 subject to treatment and confounder can be obtained using logistic regression analysis with y as response variable and t and c as covariates. For different types of y, other generalized linear models or machine learning techniques may be used. So this is about standardization. Standardization method for causal estimate treatment. This I have taken from this article. So this is the standardization method here. Then another technique is doubly robust. So let n sub 0 is prediction of y from linear regression between y and x for units which were not treated. And m sub 1 is prediction of y from linear regression between y and confounders for units which have been treated. Then average treatment effect formula becomes this. So let us see an example in Python code. So these are the libraries. I will use the causal lib package. This is a very versatile package. It has a lot of functionalities. So these are importing of various functions and methods. We will use sklearn for background logistic regression and linear regression. So we will load the inbuilt data in package. So here X are confounders, A is treatment variable, and Y is outcome variable. So first method propensity score. First of all, we frame our learner. So it has a logistic regression in background and we calculate IPW. And from IPW, we compute propensity scoring for those units which are treated and for those units which are not treated. Then IPW method, first of all, we frame our learner and the background method is logistic regression again. This is the same code as we have seen before. So we fit IPW. Then we compute the weights. So these are the inverse propensity weights. and then we estimate the average outcome and average treatment effect, which is 3.47 in our example. This is thorough evaluation of our model, IPW model. Then we do covariate balancing. This is the figure for covariate balancing. These are all covariates or confounders. So this is the triangles are unweighted and the circles are weighted. So weighted are all less than zero point 0.1. So this is the cutoff 0.1. So every after weighting they have their effect is same. Then this is the standardization method. This is our learner. So in background we have linear regression here, and this is the estimate, and the average treatment effect is 3.46 in our example. Then this is the ratio. Then this is the doubly robust technique. Here we have in the learner we have the logistic regression here and stratified standardization, and this is the average treatment effect 3.386. So this is all for today. Thank you very much.